Welcome everyone to another meetup of the Data on Kubernetes community. This is our meetup number 41. This is our second meetup of the week. Always very excited to be here. My name is Bart Farrell. Gorka, if we can get the links on the screen. If you are new to the community, you can always check us out on Slack. You can check us out on Twitter. You can check us out on LinkedIn. We're doing meetups in English. We're doing meetups in Spanish. We actually have a meetup in Portuguese later today. We have a meetup on Spanish next week on Monday. Looking forward to doing our first meetup in Hindi at the end of this month. Other things that we're looking forward to, Gorka, if you can share our screen. Gorka is our wonderful technical director. Just going to show everybody a couple of announcements that we have going on. We will be hosting a Data on Kubernetes community day in KubeCon. All right. So Gorka, can you go to the top actually and go to where it says, yeah, it's fine. Review, no, to the top. All right. The other top. Yeah. To where, all right, good. So we'll be hosting a co-located event in KubeCon, all right, on Monday, May 3rd from 10 a.m. to 5 p.m. Central European Standard Time. So it means folks in the West Coast, Evan, you would have to get up very early, but there will be talks all day. So there'll be things happening later on as well. Registration is totally free. If you're already registered for KubeCon, you just have to add it. If you're not registered for KubeCon, you just have to contact us. We'll be happy to get everything sorted out there. I was very excited about that. And that actually ties in very well to what we're going to be talking about today with Evan, because a lot of the basic notions about this community is how to be, working with stateful workflows, stateful applications in a cloud native environment. So it ties in very nicely. Evan is no stranger to this. I will let Evan obviously explain his background more in detail. As usual, this will be a pretty open conversation. So anybody that has questions, feel free to put them in the chat. Also, Evan's been very generous and gracious about answering questions in our Slack. So whatever questions we are not able to address today in the meetup, we can continue the conversation there. That being said, Evan Chan, who are you and where are you?
Hey everyone, so it's great. Thank you, Bart. It's great to be here on the Data on Kubernetes community. My name is Evan. I'm a senior data engineer at Urban Logic in Vancouver, BC, Canada. And like what else? So I've been doing basically data work, data architecture, data pipelines, data engineering for a long time. I was an early member of the Spark and Cassandra communities. When Spark was not 1.0, and I've just really loved working with data and working with other people that work with data.
Very, very good. And in your experience, when did this notion of data on Kubernetes, I don't want to get any spoilers because I know you have some slides, but because we've been talking to different folks about when was the first time you heard about it, or when was the first time it was considered, or what was the first conversation that you had? What was it like in your case?
Yeah, you know what? I think, yeah, so I will get into this a little bit, but it did feel like for a long time, like you heard about Kubernetes and it was about stateless, it was like, and people thought, well, databases are kind of, and data is kind of separate. And so I feel like this is a more recent, maybe like the last, like maybe 2 years or something, like it's hard to put a date on it, right? But like, yeah. That's when you started really hearing about, oh, people are running like, data workloads on Kubernetes, and then they started adding features, right? And they started adding the persistent volumes and the stateful sets and things like that. And I think that's when things started to really gel. And now you have, whole companies and whole ecosystem that's really coming alive around that. And yeah. I'll get into that. Basically, I'll be talking about state. What is state? Where does it live? And what does that mean in the context of Kubernetes?
Very, very good. Outside of the context of Kubernetes, can I ask you, how often do you use the word ephemeral?
Oh, that's quite funny. Like I think ephemeral probably more often than you think, just because there's so many things that are like comes and goes. Of course, everybody is on Kubernetes, but even before that, there were infrastructure would go down. So you have to assume that things might be gone,
Like you said, is that, temporary, could be here, could be there. Like I said, it's just funny because sometimes there are words that, like I remember learning the word ephemeral because of doing, I don't know if you did the SATs to go to college, but I remember that. I mean, it was one of those SAT vocab words that everybody had to learn. And so now being able to bring it back into this context of statefulness and statelessness, it's kind of nice. But anyway, without further ado, if you want to jump right into your presentation, we can take it from there. But just like I said, just a reminder to everybody, feel free to ask questions. This is your time, so take advantage of it.
Yeah, feel free. Just want to let this be kind of like an open thing, So without further ado, I will attempt to share my screen.
Okay.
And hopefully everyone can see this.
Yep.
And then at the end, I'll unshare it again. So designing stateful apps. I gave this talk in November at a data conference, and the name is escaping me now. But to launch right into it, a little bit more about myself. So I'm a senior data engineer at Urban Logic. So Urban Logic is really neat. We are actually you might have heard of these data for good events where people go and hack on open data to try to improve their communities, right? Like maybe they go and take this data and figure out how do we make, I don't know, let's say improve transit or something like that. Well, this is what Urban Logic does. We actually make online data solutions for government that helps them plan and do transit better. And so that's really, really neat. I'm the creator of a distributed time series database called FileDB, which is basically distributed Prometheus. It is at use at Apple. And I've been doing big data for a long time, especially with the Spark and Cassandra communities, did Scala for a long time. I'm now into Rust as well. But by the way, just a really short promo thing. I will be speaking at KubeCon on the Rust Day track also. Ooh. So feel free to check that out. Yeah.
Very good.
And lastly, I love to take photos. So if nothing else, feel free to follow me on Instagram.
No, that's good.
So,
it's always really nice. And
yeah.
It's always really nice. And we can probably talk about this later because like we had a meetup a couple of weeks ago with Tiffany from Harness. Shout out to Tiffany, where we compared.
I saw that. Yeah,
it was super cool. So
cool.
anyway, we'll definitely have to mix that. Can I just ask though, what if somebody out there wants to create their own database, what are some things they should keep in mind?
Oh boy. Like, I guess nowadays it's like, a lot of people are like trying to do this, or I wouldn't say a lot of people, like most people aren't trying to create databases, but some of that will be in this talk, right? But basically, I think it is, the really hard thing is what is the focus? Because there's so many databases out there, right? Not just the type of database, but because it is in general kind of a crowded field. I think there are a lot of niches, and there's a lot of room to do your own. But in general, it's like, what do you want to invent? And what abstractions do you want to build on top of? And that's one of the things. Like, I think actually Kubernetes becoming a good platform for doing this kind of thing, for doing serious data work, because it is starting to provide some really interesting abstractions. Because not everyone, you don't always need to invent or reinvent or redo every hard problem in, say, database and distributed systems. And a lot of people rebuild on top of existing platforms. So I think that's what I would think about is what is the, like in general in data, what is the unique thing? What is the unique contribution you're trying to do?
Yeah.
And
in the sense that, to be able to stand out, because like you said, because there are so many databases out there in that ecosystem, what's the unique selling point? What's the added value that you're going to be providing? Anyway, we can take a look at that later though.
No, I mean, just really quickly, I think someone asked this question on the Slack about why we created FileDB. So this is a case in point. When we started the project a couple years ago, 3-4 years ago, basically Prometheus had just come out. And everyone, we love the query language. We love the idea behind it. It was just that Prometheus designed to be single node, and we really wanted something that was scalable and distributed. So we started working on that. But that's and at the time there wasn't anything. Now there's more stuff that's out there. So just an example. So state. So state is really hard, right? It is maybe the hardest problem in distributed systems is what to do with your state. And I love this quote. This is quite funny, that there are only 2 hard problems in distributed systems: exactly once delivery, guaranteed order messages, and exactly once delivery. And I think hopefully everyone gets it. It's that the exactly once delivery is actually really hard and it's very easy to repeat stuff. So what kind of state do we have? There's so many different types. And that's what makes this fascinating, right? There's the traditional structured tables, the stuff that fits into your SQL database. We have a ton of semi-structured data now with logs, with JSON, all kinds of stuff. We have graphs and networks, which are becoming increasingly important in machine learning. We have a lot of unstructured data. We have configurations and passwords. We have a lot of now domain-specific data, such as machine learning models, parameters, features, this sort of thing. So where does it all go, right? And more importantly, we want to think about what are the characteristics of the state that you have. Is it mutable? Is it immutable? How does it change? How temporary, permanent, or there's that word ephemeral is it, right? What are the persistence characteristics you want? What about availability and latency? Like how fast do you need it? How much, do you need it all the time? Is it okay if it's not available some of the time? And there's this notion of consistency, which I won't go into, but is a big deal in distributed systems. So now, I think Bart has just asked this question, but a couple of years ago, like we all thought of Kubernetes as this stateless thing. And so the idea is you put up your applications to Kubernetes, and then basically the state gets punted. So this is what I call Kubernetes stateless. This is like the traditional app. It shows up, but it doesn't keep any of its data. And it will interact with a lot of outside entities. So it might be talking to some, say, Postgres database in RDS or something. Maybe it's talking to Mongo, and you got, things, cloud storage like S3. And so basically the app is doing a lot of these reads and writes to these different entities, and all the state is kept in those entities, right? So this is the classic, what I call the stateless pattern. And that's fine. Let's go into this in a little bit of detail to think about what is really going on. So where is my state? So Kubernetes has containers, and a container has read-only disk images, which are the files you have. You have layers of them, and it builds up. And then you have a temporary local disk, and then you have memory. And what we find is that, and then you're reading, writing to and from cloud storage, and you have something else that is sending requests or events or so forth, right? So you can have state in any of these places. However, what we find is that the memory and local disk are not persistent, right? They're kind of ephemeral. If the container fails, it gets restarted, or something happens, that memory and that temporary local disk is gone, right? So this is why we keep all of our data in some external, what I call, cloud storage. It is external to the container. But wait, I thought stateless solves all my problems. Well, this pattern I think can work for a lot of scenarios. Here's the thing. If all your state is pushed to other services, you find that you have to work with a lot of these services, and the costs start adding up. If every state change involves the network, you start to add a lot of latency. You have to deal with recovering local state. Now there are many ways around this, but there are most of the cloud providers will try to sell you on their services. Like you have things like Dynamo, Kinesis. So you start being tied to certain clouds, and keeping state consistent across the cluster can be tricky. So there's a lot of issues that have to deal with the state. So this whole talk is talking about what are some other patterns out there that we can use to deal with the state. And before I go on, I want to compare a little bit between stateless and serverless. This is a really big topic, or a really hot topic, and feel free to ask questions again. So what we find is that, well, in a container-based environment like Kubernetes, you have the memory and local disk, where you can basically cache, you can keep track of some state that is not persistent and disappears, but you can use it. The difference is serverless is, so compared to what I call stateless Kubernetes, there is still state, it's just that it's not permanent. The memory and local disk can be used. But when you have a serverless environment, you're basically serving a function where the life cycle is a lot shorter. It is basically like one invocation. So even the spaces that are temporary in a Kubernetes container are not available to you. So in a serverless environment, you really have to be truly stateless, where like everything has to go in and out through another cloud service. And that brings us to our next point, which is how can we take advantage of this local ephemeral state within your container, right? So you have memory and you have local disk. This is what we call local state. It is local, and we can use it to our advantage, even though it's not persistent. So basically, it is we consider a two-tiered approach where we can keep track, we can build up some state that is local, and then we can perhaps reduce the I/O. We can do things that can improve the performance, the latency of our applications. But the problem is that this goes away. So how do we deal with, if we take advantage of this local state, how do we deal with it going away? So that's one of the big challenges with working with state. And the classic pattern that I wanted to bring up are using what called a log pattern. This is basically writing a series of events. And we can compose our state using events. You can say that my events from 0 to n builds up the state in my application. And this is really powerful because then with a log pattern, we can have checkpoints. And the checkpoints correspond to the state at a certain time in, say, our cloud storage, right? So using this pattern, we can then recover data if we lose some temporary local data, as long as we have this log that is persisted somewhere, right? So it's basically the foundation of all modern databases and data systems, right? So are folks fine with this so far? Okay, I guess no questions. Well, let me go into an example. Maybe this will make it more concrete. So in PhiloDB, for example, this is actually, this is not, I wouldn't say it's necessarily typical of database, but we basically built the architecture on top of Cassandra and Kafka. And what happens is that millions of time series events that are really small, like your metrics, they come in through Kafka and they go into each node. What we do there is that we use large amount of memory and local disk to cache things and to build up a representation that is a lot more compact. We basically take the metrics that contain tags and contain, say, a timestamp value, and we build up a really compressed columnar chunks. Then we turn basically millions of samples that come in per second, and we turn into thousands of writes. So we basically decrease the write amplification by several orders of magnitude before writing to Cassandra. Now, because we have to build this up, it takes some time. So we have a significant amount of local state, right? So what happens when we might lose this data? We also use a Lucene index, which is on disk. So what we do is that we persist this stuff and we're writing it. But at the same time, if we lose this node, we would use Kafka as a write-ahead log. And we would have a checkpoint that says, okay, this is the last time we wrote this big batch of stuff to Cassandra. And from that time onward, if we lose any data that is local and temporary, we can read the data back from Kafka and recover that. Right? So that's a use of the log pattern to recover your temporary data that's local. And you can think of this log pattern as a kind of a stream processing pattern where you are taking logs, building up some state, and outputting data. And I call this is also called an event processing pattern. So now let's talk about stateful Kubernetes. Before I go on, maybe you should take a quick break to see if any questions or anything.
And for you, in throughout this whole process with all the different things you've been mentioning, what do you think is probably the trickiest concept for folks to grasp? Or I mean, what are questions that you find that are frequently coming up when talking about these things?
I think that's a good question. I think
Yeah, I mean, just because, like, for example, in one of the main talks that we're going to be having in May is that, like, tracing the journey from becoming a DBA to an SRE. And
oh
so
nice.
what are the things that you need to put in your backpack? So I'm saying, like, throughout this, like, is it a question of mentality, getting hands-on experience, getting certified or something? I mean, what kind of recommendations would you give?
I think a lot of it are in the details, like when I talk about, logs, like at a very high level, it makes sense to people. But when you start getting to details, like how does recovering data work? How do checkpoints work? I think a lot of those things start to become really complicated.
Mm.
And so I think part of it is, yeah, getting experience, like dealing with, say, data and databases and checkpoints, and like, what does it mean when failures happen? Some of it experience. So from experience, like, especially SREs would know what happens when checkpoints go wrong and, things
Yeah.
like that. And I think a lot of this is because it's kind of abstract, and like a lot of times databases are magic things. And when you get into weeds of how to operationalize them, how to keep them up all the time, then you start really getting into the quote unquote fun things.
Yeah.
And
So a little bit of
yeah,
patience is required to get to that point.
yeah,
We got it.
absolutely.
Yeah, we got another question. So how do we map a generic database on bare metal versus a containerized stateful set based database? Does this mean one pod is one node?
Okay, that's a good question. I'll get into that actually in a few more slides.
Okay.
Yeah.
Hold your breath.
Yeah. So hold your breath. Yeah, hold your breath a little bit.
Yeah. Okay.
We'll talk about. I'm about to launch into like the stateful sets stuff.
All right. Good. Go for it.
Feel free. I don't know. We'll answer your question, but hopefully it will.
Yeah.
So wait a minute. Okay, here we go. So persistent volumes. I think most of the listeners are probably familiar with this, so I don't think I need to go into this in any great detail. But this is a storage abstraction that is persistent and survives pod restarts. So this is great, right? Because the local disk temporary storage is not, right? And so that means that the memory is not persistent, but now you have something local that survives restarts. And this is something that has basically a persistent volume is seems like a local volume. You can use standard POSIX file IO. It is mounted, and you configure it with YAML as usual, but you can configure what kind you want. There's tons of different options out there. There are local persistent volumes that are a hard drive. Basically, they're attached to the node that the container is on. And with stateful sets, you actually get that back. And then there are ones that are networked and attached to one pod at a time. This is things like EBS and Azure. So each cloud provider has their own, but then there are also other solutions that are out there, Staff Scale IO and OpenEBS, which is a really great solution. And oftentimes you can tune them, but you can oftentimes get performance that is close to local disk. And then finally, you have replicated shared network storage where multiple pods can attach and share data. And there's a lot less of these. The classic one is like NFS, but there's a bunch of other ones like Gluster and Ceph, et cetera. Right, and I think everyone's probably familiar with this, but you can basically configure your parameters, the type of volume that you want, and what kind of storage you have, and the provisioner is what type of things it is. In this case, it is at EBS. But the really cool thing is that you can basically configure your storage characteristics at deploy time. Your application just has to worry about, well, it is a local disk. All right. So I think someone had asked about stateful sets. So stateful sets are an abstraction in Kubernetes that ties that remembers the persistent volume that is attached to your pods. So so that when let's say a pod fails or you're upgrading, it will make sure to for example, an upgrade cycle, it will detach persistent volume, then it will allocate your new pod, and it will make sure to attach that previous storage again so that you get back your state. And because of that state, the usual pattern of upgrades changes. So the order that it would go through, the order that you would go through the upgrade cycle changes. It goes through the pods and makes sure that the PV is detach and then attach again, and so this can take a while. This is one of the trade-offs, is that sometimes it can take a while to detach their persistent volumes. I will get into this database thing in a minute, but you might ask, why do I want to use these persistent volumes and the stateful Kubernetes?
We got a quick question. Somebody asked,
sure.
Sorry, Robert asked, how long is a while? Time is a very relative concept.
Okay, yes, that's a good thing. I mean, I think I think it ranges from seconds to, like, I've heard minutes. I think what I like gathering this information from various people. Like, I would actually love to hear your own stories about this, but I've heard a good rule of thumb is like, something 90-some percentile is like around a minute, but I think it depends heavily on what type of attached volume you have. And I'm talking about network ones. Obviously, like the local ones are a lot faster. But networked ones, I've heard that it depends on, for example, if you use EBS, it can depend on how much you provision. And if you provision less bandwidth or storage, it might take longer to detach. Or that oftentimes people will over provision to guarantee a better detachment time and things like that. But I think it varies on environment. I'd actually love to hear what,
Robert, did you have any time frame in mind there? You can just put in the chat. Does a minute sound like it's long? Does it short? Anything relative to that? Like you said, there can be different strategies depending on, what people are looking for. Well, anyway, you keep going on. And okay, here we go. Yeah. As usual, he says, as usual, depends on the use case and what you need, as you mentioned as well too.
Yeah. I mean, but I think usually the more you pay, the better performance you get. Unfortunately, I mean, but right. So let's look at. Oh, sorry, I skipped over this. So you might want to run stateful service and database yourself to save money, right? This is typically where people interact with persistent volumes. Is they want to run your straight SQL database on persistent volume and handle that yourself to save some money because it's cheaper than using RDS. But there's a lot of other use cases. If you're doing data engineering, you'll be working with machine learning models. Data engineering involves a lot of files, right? It could be models, it could be local files, CSV files, what have you, right? And just throwing away that state could be expensive. So using persistent volume is a great way of keeping your data transformations alive for a lot longer and lowering your recovery time. You might want to use local state to cache things. Maybe you're pulling files from S3 and having that local cache, just, saves you from a whole bunch of network out to S3, right? And I would say that local files are cool again. That I'm going to go into the history of databases again, but things have gone out to the cloud, but at the same time, like having this abstraction, like there's a lot of performance reasons for doing this as well. And finally, if you design for persistent volumes, the really cool thing is that it is one abstraction. You can basically take this design something that works with local files, and you can use it on any cloud. This is widely supported, and like you can configure it, and like going to different clouds is basically reconfiguring your YAML. So that's a really nice property. You're not talking about changing APIs and so forth. So let's go into this common case of replicated databases, right? So typically for a standard database, you have a leader pod and a couple follower pods, and the whole idea here is that with traditional database replication, you get better availability, plus you have this backup, and so on, right? And you would so the things that you would need to think about and take care of is what happens when if one thing fails, and you would want to be notified, so that let's say the leader fails, the follower, then you have to bring it back up. Depending on the exact database, you might need to issue some commands to reconfigure things for a while, and fortunately, there are actually things to help you out. So people have started coming out with. So there were times when, depending on the database, like this would be like very, very manual and having to change like network settings and so forth. But now there's a lot of automation built around it. There are Kubernetes operators that are out that can help people do this kind of thing. Like I think there's one for PG, and it will automate a lot of this stuff with having multiple replicas, leaders, followers, replication stuff. It takes care of a lot of this stuff for you. So that I would definitely recommend people check that out. Another example of, well, this is a little different, but if you're running Apache Cassandra, Cassandra has has multiple replicas for each shard, right? And it needs to be set up in a certain way, and that didn't necessarily map well to the way that the Kubernetes stateful sets worked. You could have one set per bunch of replicas, but that does not necessarily, like, things need to be laid out a certain way. Like ideally, you want the replicas to be in different racks, so that to minimize the chance of failure. So to help automate all this, people have started coming up with operators again for things like Cassandra, because some of the operations, like setting it up, would be like pretty painful otherwise. Here's a fun thing, a brief history of databases. So in the beginning, people had one server and one disk, right? And after a while, of course, this was not adequate. So people built bigger servers with a lot more memory, and the disks got bigger. And people would spend tons of money on these. Like basically, it's the same model, right? It's a single server, and all the database, would hopefully scale with this memory and this storage. And people sunk tons of money, right, into these storage solutions that would distribute over a network and whatever, but the model was still the same. You have a single server. And again, this became very limiting after a while, and people found out this was not enough. So to scale, we started turning to distributed systems. So now every database figured out a way to replicate and shard their data. And now things get a lot more complicated. Different nodes talk to each other. You have different shards. Like there are tons of different models. You have the leader follower. I don't like to use the other terminology. And
good job. Thank you. No, seriously, good job.
Yes, I spent some time renaming all the branches on our repos, but and you have the other model where you have replicas, and so there's different models out there. But basically, the idea is, let's use commodity hardware. Let's scale out, to a lot more nodes. So this works, except that, of course, like things get a lot more complicated, because now every data application or database like thing has to figure out, how do I coordinate? How do I replicate? How do I distribute? And this is basically the hardest problem to solve, right? So the big point here that I wanted to make was, around 20 years ago, like with, Google came up with their distributed storage, and then Yahoo followed with Hadoop. And this was a really big breakthrough. It's not just about big data processing, but the really big breakthrough is the power of replicated file storage. Basically, it was HDFS. And what HDFS did is it said, here is this storage abstraction where I have a giant network disk. I don't need fancy hardware for it. I don't need to buy RAID array. I don't need to buy fiber channel, and tons of nodes can share this. It is storage that is replicated. And I know that it has a very good guarantee of safety. You know, I put stuff on there and I don't have to worry about it. And what this did was that this common layer that had this powerful storage abstraction, tons of applications started building on top of it. MapReduce first, but other things, you started to have HBase, and other things came along, you know, Storm and Spark and Pig and like Mahout for machine learning. So this abstraction where you have these files turned out to be so powerful because it allowed all the data applications on top to not worry about that layer. They just used the storage and they just worried about how to build this for their stuff. And this turned into this huge the basis of the modern big data ecosystem is all built on top of this file storage abstraction. So it is extremely key. And the key takeaway here is maybe we don't need to reinvent distributed coordination and replication in every data system. You know, like maybe we can use this abstraction, right? And that brings us to stateful Kubernetes, that we have this abstraction, which is quite powerful. We have basically a cloud native storage abstraction, which you can configure at deploy time. And it means that applications don't have to worry as much about this, like say this replication part and things like that. It just has a disk that is out there and it is done for you. And Kubernetes is also extensible, which can make this work for like the previous case we pointed out, like the databases. It has operators, it has CRDs. So whatever needs that there are around, well, you know, this needs to be done at upgrade time, you know, you can automate that, right? Which is really, really nice. Basically, the previous example with FileDB where I had Kafka and Cassandra. So at the time we started, this stuff, the persistent volume, stateful set stuff wasn't really there. You know, if I was to design it now, I would design the solution around like persistent volumes, like all the stuff we basically did a lot of stuff so that our Lucene local disk files would be persisted somewhere. And I don't have to do that anymore. You know, we would just put the files on the local disk and you would just forget about it. I would even put the log on the local, when I say local, what I mean is the PV. It's, you know, like probably for persistent reasons, it would not be local, or it could be local, but you know, what I mean is that a lot of the things where we would punt off to cloud services like Kafka, we could have a lot of that local. And that changes the cost equation, you know, quite a bit. It means that we have a lot of our state can be how we persist it and recover it. You know, the model becomes simplified. You know, so and you can use this as a building block. So, for example, your app. I wouldn't say instead of, but you can think of this as an alternate pattern. You can use your local disk, and you can use things like, you know, local KV stores, you know, your RocksDB, your local, like, you know, there's a lot of embedded databases that can be built into apps, and things like Lucene, you know, machine learning models, files. You can build that into your PV, and you can use one of the replicated ones like OpenEBS, and this takes care of your replication and your failover. And it uses different shards, right? So this is a trade-off you can think about, having this local thing and using this storage as an abstraction. And you can even use different kinds of clustering layers to help you coordinate the different apps. one I've used a lot before is something like, Akka is like distributed actors, but there's a lot of stuff out there. I feel like I just went over a lot of, well, let me go over one more slide, then we should probably pause.
No worries. And I have a question about sharding. So
Oh, yeah. Okay. Yeah. What, go ahead. Yeah. Why don't we?
No, just because very famously in one of our meetups, precisely where we were talking about, is Kubernetes ready for data, is that Patrick McFadden from DataStax, shout out to Patrick, was saying, as this quote of, friends don't let friends shard. And so anytime the term sharding comes up, it's something that we always ask our speakers. Why do you think he would say that?
That's a good question. That's a good question. I think that
or perhaps that's what I'm saying is that what would your precautionary advice be for someone in a situation like, hey, this is the option we're going for?
I think I would say that it's, I'm not saying, hey, this is the way you should do things. I think this is a really interesting option. Like a lot of people, it's like this, right? Like the way people had solved a lot of scaling stuff, they sharded their databases. Then we opened up and had things like Cassandra, and Cassandra is a wonderful database. I love that community. It's just very different. It is a very different data model. So oftentimes when people move to that data, like people don't realize that things like the database. It's kind of like this. There are trade-offs. The ideal is, of course, that you could have the pi and eta 2. Like you could have a lot of people want, for example, like a distributed SQL solution or something like that. I think what you have to realize that a lot of the distributed, like database that were built out to be distributed, use a different data model. So they're not like full. A lot of them are not databases where you store your data and you can run all kinds of queries on it. Like Cassandra is like that. It's good at certain things, but it has to fit your data model. Mm-hmm. I used to think, why do people shard? But for a lot of applications, sharding actually works really well. And it's if it works for you, like Facebook does this at huge scale. If it works for you, go for it.
Yeah.
I think it's kind of like that.
Okay. Good. No.
Because there's also a huge amount of history and maturity in database products that are out there, the Postgres and that kind of thing.
Oh yeah, we start talking about Postgres. I mean, we've had multiple Postgres meetups, but it's battle tested, decades of people all over the world working on this. So there's no shortage of experience or know-how when it comes to that.
So I think basically, like for me as a kind of data person and architect, I think I used to be a little bit more opinionated about this, but I think now it's like I think there's many ways to do it, and I think I think sharding is just obviously again you have a lot more pain when you're trying to merge stuff from different things. So it works for certain use cases, and it's not going to work for other use cases. And for those other use cases, maybe you need to just pay money and have to distribute SQL database.
Like you said, it was the same thing about the timing question earlier. Is what's your budget? That is going to play into that. That is a factor. It's not the only factor, but it's one to keep in mind.
But I think some of these there are layers that will help you route your data. Like I pointed out Akka because it's one of these things that has like a notion of like basically it helps route your data and get things from different places. And so there are also ways you can build your application that way. To help bridge these different things.
We got one other question. What options do you suggest for meeting zero RPO requirements around stateful apps?
Sorry, what is that? Zero
RPO requirements around stateful applications.
Got it. I'm not quite sure what the RPO is referring to.
What are we referring to here with RPO? Oh, recovery point.
Oh, zero. So basically they want to not have to worry about recovery. at all.
Sorry, recovery point objective. Thank you, Robert. Yeah, recovery point objective.
Got it. Have to chew on that a little bit. I'm not quite. That's probably I'm trying to map that to another term.
Yeah, the time it takes to fully recover the app.
Yeah. Okay, got it. So basically, they want zero recovery time. Well, yeah. I would say that there's never such a thing as like absolute zero recovery time, but like you can get really close to it, right? Like,
yeah, they've kind of clarified here, saying meaning no data loss.
Oh, no data loss. Yeah, I mean, I think in general, like I think there are general patterns out there, right? Like the log pattern that I mentioned is a good one. That basically, like, in order to make sure you don't lose data, you have to basically use an abstraction like log to protect the transient state that you have. Like you almost never have like zero transient state. So it's more about how do you minimize the gap to, like, how do you minimize the gap of your transient state? And what I would say is that the further away that things are, for example, like earlier when InfalliBly we had put our state in a Cassandra and in a Kafka, the further away things are, generally the more transient state you're going to have, right? Because like it takes longer to reach that, that persistence. So I would say that you can try to minimize the gap by, like, if you move to something that uses a local disk or persistent volume, that can help minimize the gap if those things minimize your latency and like how fast you can write, right? So that and the smaller your transient state is, then the more you can minimize that gap. And you can try to make it as close to zero as possible. It just depends on how much engineering resource you're willing to throw at the problem, right? So I don't know, that helps answer that. At some point, then you decide it's good enough is usually where people end up. So I want to talk a little bit about this machine learning case, which I think really neat. This is a slide from Amazon. You don't have to use Amazon, but the idea is I can have a pipeline that writes some data, say models or training jobs. It can write it to a shared persistent volume. In Amazon, they call it FSX or something like that. There's other ones out there. And then I can serve this using Kubernetes pods that mount this volume. So this is a cool abstraction. People would use things like HDFS for a lot of use cases like this, but this is a way that you can do this on Kubernetes. I think having a shared volume does make it a lot easier to map like distributed jobs to serving training models. But yeah, so this is a really neat use case. And I think the really big deal when asked about data on Kubernetes, I think the really exciting area opening up is going to be machine learning on Kubernetes, So this is happening, but a lot of exciting stuff happening. I don't really have to go over, but basically just some trade-offs for considering the use of, and by the way, this is not an either or, but this is basically trade-offs for cloud data services versus persistent volumes. So we have cloud data services, the replication distribution is handled by the service or database. With persistent volumes, basically you configure how things were replicated. You can decide for no replication, or you can usually configure a number of replicas for networked PVs. But they are usually, I would say usually, local to a pod. And so the app would need to shorten handle. One exception is that if you use networked ones, then you can share, sorry, not network, but if you use something like Gluster, you can share data more easily. So that's one way that you can easily share things and have to do less coordination. You are comparing a standard POSIX API versus different, database service APIs, and you have closer to local disk latency, but you have different considerations for handling your data. So that's about it. And in conclusion, think about your state, what kind of state you have, and the characteristics you need. And know that there's a really wide spectrum of design you can stick to the serverless or the stateless model with using cloud services, but be adventurous and don't be afraid to venture into using more local state and taking advantage of everything that Kubernetes offers you with persistent volumes. And I think that's about it. I'm happy to take questions. Oh yeah, and I'll leave it on this slide. So feel free to reach out to me on Twitter, Instagram. I love more followers.
Yeah.
And I have a personal about page or blog with some random stuff on it. So
okay. Good. We got all the places to check you out now, because we did talk about this in the very beginning, is that you are an avid photographer. So as we were saying previously about tracing this journey from becoming, DBA to SRE, when did you start with photography, and how could you maybe relate, how you are a photographer now with also how you see databases now?
That's wow. That's kind of a big question.
Well, let's just start. Let's just find out about when did you start taking pictures? When did you start with photography?
Yeah. So I think it started a long time ago. Like after college, I was taking I wanted to take a community class on photography. At that time, they were still doing film. So I did like black and white and actually go into a dark room and stuff. Nice. And I thought that was like really cool. Just this was kind of magic, like watching the chemical process work. And it's been kind of on and off, like it's a lot of things happen, like, had a family and stuff. I think more recently, like
that'll do it.
I got the big like SLR stuff. And after a while it became heavy and I kind of like, stopped really being into it that much. And more recently I've gone into it more because I started to discover mirrorless cameras, which are really small. So they were like small and I could carry them around really easily. So then I started doing a lot more and I started incorporating more like digital techniques. And this is where it ties into like the SRE stuff, like, started to think about how do you manage like this huge volume of photos that you have, like how do you back up, and what are good cloud services for doing backups, and how do you organize your data, and thinking about how to organize it in a way that is transparent and can survive, kind of like provider independence, like I like to keep my data so that it's not just all like Adobe's property or something like that, So
yeah. No, but that's precisely it. I mean, like from having conversation with folks in the storage world, like we had Gary, the CTO of Cloudian on, and that's exactly what he was saying, is that like in the same way that if you have your couch and your family photographs in a storage room, like you don't want that storage room being sold to somebody else who can then do whatever they want with your stuff. So it just, whether it's like you said, whether it's photographs or the famous example of cat pictures or things like that, we need to find a place to keep our stuff. I think though what you were saying is that the sort of evolution is that the questions that you're thinking about, the scope, the different possibilities that can come into play, I think that might have something to do with it. But I think the other point here is understanding the importance of being a lifelong learner. And that no, I think you're right.
There's so much to learn in every field, and I think you have to keep learning. And there's no better time for learning things. Like there's so many like things like podcasts and like blogs, and there's so many resources like that. This is just the best time that there's ever been to learn things. Like even the kids that are home from school right now or can't like necessarily go to school, like there's so many resources now for them compared to like they can pick up just about anything online.
It's true. So no, it's very, very true. The access to that information is much more readily available. Another thing. Okay, so this is one of the questions that we had that I tossed out on Slack. But what is the most complex thing in your opinion about working with data?
Specific to Kubernetes or just in general?
Maybe we can think about it from let's think about it in general first, and then maybe turn it over to Kubernetes.
Oh, okay. Yeah, I mean, I think. I think it's definitely like recovering state and not losing data. Like someone that asked about how do you minimize that, right? I think this is the challenging things. Like I think it's like easy to work with data if you don't care about throwing it away. That sounds kind of trite, but
it's true, right?
I think it is true that like not losing data is a really big deal, and I think this is kind of why I like working with it. It is really hard in that way.
Precious element,
especially. Yeah. Moving data, like streaming data, is even harder, So I think that is really yeah, I think that's it. Is recovery and checkpointing, and then the other part is for distributed data. How do you keep it consistent, and how do you balance consistency and availability and other things? And yeah, that I think that is I think those are the hard challenges.
And would you say the same thing would apply in the Kubernetes space?
Yeah, I mean, I think it does. I think that, but I think, and I think this is one of the stories is that having the abstractions that, like, we have folks like OpenUBS and staff and other people trying to take on the hard problems of how do we keep from losing data. Once, obviously, you have to get it to their platform or persistent volume first. But I think that helps solve part of the problem, though, and makes things easier, because that's one less thing that you really have to think about. Is I have to get something there. Once it's there, then data gets replicated and preserved.
Yeah, I think it's a really good point. And just one other thing I wanted to think about as well, too, is because you mentioned, upcoming trend, machine learning. What other things? Yep. Oh, we got one other question as well. Any gotchas on how to proceed with moving existing databases such as MySQL, et cetera, into Kubernetes?
Existing databases. Well, I think, I don't think there's anything magic about running them on Kubernetes necessarily. I think what you would want to think about is just the the storage aspect and what are the characteristics that you want. It depends on where, when you say migrating, there's somewhere you're migrating from, right? So is that your is it already in some cloud, or are you migrating from RDS, or are you migrating from some bare metal or something so then you have to think about the characteristics. Like for bare metal, you're used to a certain reliability, and when you move to the cloud, you could use the most reliable persistent volume implementation and pay more for that. But it's kind of you have to realize the trade-offs. You're moving to something that might be a little less stable, is your backup game and replication game up to speed, and I think you have to triple check the operational aspects, and think about the storage characteristics and things like that.
All right. As you said, depends on where you're going from, not just where you're going to. But apart from machine learning, do you expect any, in the upcoming 6 months and the rest of 2021, any new things on the horizon for the data on Kubernetes space?
I think you had mentioned one of your questions about multi-cluster, and I think that's really interesting. People do want to. I think that is still a field that is probably underexplored. It is how do we back up data across clouds? And for example, Cassandra is popular for this reason. It has a I said multi-cloud, but basically it can replicate across clusters. So I think this is something that we'll probably see more movement on. Maybe we'll have custom operators and things like that can coordinate. It's just you need to coordinate things. Hey, if Amazon loses a whole data center, how can we make sure that my Kube cluster and some other geographic regions are up to speed and can recover it? So it's coordinating that stuff. I think we'll see movement in the space.
Mm-hmm. All right. Very, very good. Well, that being said, we are pretty much out of time, but as always, if folks have any questions, we can definitely take the conversation to Slack. I had a couple other questions that we weren't able to get to today, but we do have a tradition where we always have somebody in the background who's creating a visual representation of things that we're talking about. So Evan, if I can get you to stop sharing your screen.
Yep.
So we can share our screen really quickly.
I think. Oh, I still have to click on it. Okay, there we go.
Yeah, it's all good. No worries. It's so funny. I always say this, that we're talking about data on Kubernetes, but it seems that Zoom gives us many more problems than just about anything else.
Yeah. No, I think you're right. That is true.
Yeah, if somebody from Zoom is listening, please work on your user experience because there's plenty of room for improvement. With all the money they're making, you think it would be better. There should be a hackathon for Zoom. Anyway, Gorka, if you can share our screen. So our good friend Angel was creating a visual representation of the things that were being talked about. As it was mentioned more than once, that state is hard. He even made a reference to Bob Dylan as a hard rain is going to fall. So we have quite a few different elements that were featured in there that were mentioned in the talk. But I think we can all agree that it was very, very thorough. We've had more than a couple of talks about stateful versus stateless in our community. And this was a very, very well-rounded one with very concrete examples, and definitely the first time that I've spoken to somebody who's created their own database. So anyway, that being said, thank you very much, Evan. I for all the folks who may have arrived a little bit late, you can check out his talk that will be on in the KubeCon Rust track. That's what you said?
Yeah.
Okay.
Yeah. Bart, thanks so much for having me on, and I love that graphic, by the way.
Okay, good. Yeah, we'll be sending that to you.
Yeah.
And everyone should also check out all of Evan's other links for photography, all the other stuff that's going on. Anyway, Evan, thank you very much for being such a wonderful guest.
Yep. Thanks so much. And
all right.
See everyone later.
Bye. Cheers.